Today's lesson is going to look at Chapter 23, Section B on counting permutations. Let's take three letters, A, B, and C. Now, let's write those in all the different orders that we can think of. For example, I could write this also as A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A, giving me a total of 6 different orders. These are the 6 different permutations of the letters A, B, and C. As you can imagine, if I give you 4 letters like L, M, N, and O, it's going to get slightly more complicated rather quickly. Let's go through and list all the different permutations of L, M, N, and O. So I can have L, M, O, N, L, N, M, O, L, N, O, M, L, O, N, M, L, O, N, N. And you can see that we're quickly going to add up a whole bunch of different permutations. If I was to continue on, you would get 24 different permutations. And I'm going to show you how to find the number of different permutations without having to write all of them out individually. It would take me a while to write out all 24, so I'm going to skip that and go ahead to defining permutations. A permutation of a group of symbols like A, B, and C. Symbols can be anything, by the way. They can be letters, numbers, fruits, people, whatever they are. The permutation of a group of symbols is any arrangement of those symbols. In a definite order. So in these problems, order may or may not count, but a permutation includes the order. So ABC is definitely a different permutation than BAC. These are different permutations of the same group of symbols. Now I told you I'd help you find the number of permutations of a larger set of symbols. Let's take 4 again. Let's go back to L, M, N, and O. And I told you there were 24 different permutations. Let's figure out how many different permutations there are. Think of it this way. If I draw 4 boxes, each box represents a space or a place that I can put a letter in a permutation. There are 4 different letters that I can put into the first box, right? But whatever letter I choose gives me 1 less letter that I can put into the next box. So the next box I only have 3 letters. For instance, if I put an L into the first box, I can no longer put that L in the second, third, or fourth boxes. Likewise, for the third box, I'm only going to have 2 options, and by the time I get down to the last box, I'm only going to have 1 option. Using the product principle, which we learned about in Section A, I'm going to multiply these different paths together, right? I can multiply 4 times 3 times 2 times 1, and that's going to get me 24 different permutations. Now, what if I only wanted to take 3 of the letters at a time? So, in other words, I can use L, M, N, or O, but instead of taking all 4 letters, this time I'm going to take 3. Well, instead of using 4 boxes, now I'm going to use 3 boxes. Again, I still have 4 options for the first letter, L, M, N, or O. I'm still going to have only 3 options for the second letter and 2 options for the third letter. Turns out I'm going to get the same number of permutations when I only take 3 letters at a time. Using this logic, however, if I were to take 2 letters at a time, I would only have 12 different permutations. Likewise, if I was only to take 1 letter at a time, it's fairly obvious that I would only have 4 different permutations, 1 for each letter. I'll show you how this works in a few examples right now. Let's take a look at example problem 1. Problem gives us 5 symbols. They're the letter A, B, C, D, and E. The first question asks us how many different permutations there are when we take 2 letters at a time. So remember, I have 5 choices, but I'm only going to choose 2 letters. Therefore, I'm going to draw 2 boxes. In the first box, I have 5 choices. I can choose letter A, letter B, letter C, letter D, or letter E. In the second box, I'm only going to have 4 choices because I would have chosen one of those other letters. Using the product principle, I'm going to multiply these together, and that gets me 20 permutations. The terminology here is that I'm going to take 2 at a time. I could take 1 at a time, I could take 2 at a time, I could take 5 at a time. I can't take 6 at a time because I only have 5 letters. If we look at the second part of this problem, now I want to take 4 letters or 4 symbols at a time. Therefore, I'm going to draw 4 boxes. In the first box, I have 5 options. The second box, I have 4 options. The third box, I have 3 options. And the last box, I have 2 options. So if I were to multiply all of these together, I would get 120 permutations. You probably wouldn't want to list all of those out by hand. It gets rather cumbersome. So this shortcut method is a really quick way to tell us how many permutations we have for a given set of symbols. Let's look at another example. This time we have 4 symbols. They're alphabet blocks, letters A, B, C, and D. And they're placed in a row. The first question is a lot like the ones that we've already answered. How many permutations could we have total? Well, if there are 4 letters, I need 4 total boxes. And again, I have 4 choices for the first box, 3 for the second, 2 for the third, and 1 for the last box. I multiply those together, and again, we're going to have 24 permutations. Easy enough. In part B, now we're putting a requirement or a restriction on the first box, which is that we're going to lock in B on the first box. So I really only have 1 choice. But now that limits me on the rest of my boxes as well. So I have 3, 2, and 1. You can see that I'm going to have far fewer permutations if I limit or restrict one or more of the boxes. Again, I use the product principle, 1 times 3 times 2 times 1, and I get only 6 permutations this time. I can limit or restrict as many of the boxes as I want, and that's what we're going to do in part C. I'm going to restrict the n blocks to be A and B. So in the first block, I have 2 choices. It could be either A or B. It doesn't say which one it has to be. It just has to be either A or B. And then the last block is the other option. If we use A in the first block, then the last block has to be B. If we use B in the first block, then the last block has to be A. So there's only one option here. You can see that I've already used 2 of my options, which leaves only 2 for that second place box, either C or D. Well, once I use C, then that gives me only one choice for the last remaining box. Or if I use D, that gives me one choice for the last remaining box. You can see my options, my permutations are much more limited. Again, using the product principle, I have 4 permutations. So be careful when you restrict one of the places, and think about how many options you have for each box, and you can practice more problems tomorrow in class.